Hello, everyone, and welcome back. My name is Corey, and you're my rubber ducks for the evening. And in case you're wondering, yes, this is the second video I've recorded today. But hey, I like programming, and just trying to make some progress on this project. What is this project? I'm glad you asked. This is the set of videos where we are, or episodes, whatever, where we are creating Tang. I think is that, yeah, right up there. Stands for template language. That is, this is a custom programming language meant to be a templating language, written in C++ and using standard tools like Flex, Bison, Google Test, and ICU. And we have been writing this language from scratch. That is, if we don't provide a feature, it doesn't exist in the language. And this is 100% live coding. I've been saying all along there's nothing up my sleeves. That is, I'm doing it all in front of you. All of my mistakes and all of their glory, all of my trying to figure out how to make stuff work. And we are on episode number, I don't remember, episode number 83 of this series. So let's say, what do I normally do? Make clean, and then make test watch. There we go. All right, so what are we going to try to be doing today? We're going to be taking the first step of doing bytecode optimizations, and that is we're going to, well, need to start analyzing the bytecode in different ways, and I'll show you some of this in a moment. Before we get started, what do we got to do? We got to show our git log. Nothing has changed since the end of the previous episode, and we also need to say get status, show that no files have been altered on the disk. So we are starting from scratch at this point. And if I edit tang.hpp, there we go. If I edit here, and we see what are some optimizations that I've written down. I've only written down 3 as we came across them, but let's look at the nature of them. All opcodes after a jump and before a jump target can be removed. So at 17 here, we jump to 32, and 29. 17 is a jump if false, whatever. So it could do this. But after an unconditional jump, we get here 12. We're going to jump. There is no executing 31 unless someone jumps to 31. And so what we want to do is we want to start looking at these and be able to identify them and remove them. So that means, well, there's a couple things. We need to start kind of keeping track of, well, what are all of the possible things that we can remove. What are all of the possible, I don't want to say this, changes that can be made. I'll just leave it at that. And all the possible things that could jump in here, and just we have to be able to identify for each bytecode, right? The whole point is the bytecode address is just a bunch of bytecodes, and some of them are one opcode long, one unit, if I can say that. It's really a U integer T. It's just one of them long. One of them, sure. Some are 2, some are 3, some are, if it's a string, it's multiple. And we have to be able to go through and identify for each entry, where does it occur, what's its bytecode offset, and what type of instruction is it. Yeah. So, okay, so that's one, ignoring everything after an unconditional jump. Number 2, poke, pop, peek. This was a pattern that we saw a lot, where we poke something, we pop the result because poke doesn't remove it from the stack, and then we peek it back. So it's like, well, we could get rid of the pop and the peek. And number 3, a push followed by a pop, that is putting a null val on followed immediately by a pop. We could remove those because they don't do anything. And then there are a couple conditions here that I say if 20 is not a jump target. If 19 is a jump target, it's okay, actually. Because if 19 is a jump target, then it would execute 19 and then 20. And if we remove both of those, then what was going to 19 would just go to 21. So, okay, these are the types of optimizations, and there may be more that we run across as we examine some of our code. And I have a couple in mind, actually. But we have to start writing, and we may not actually even get to anything today that will alter this. But what we need to do is we need to write something to start analyzing the bytecode so that we can, so doing a meta-analysis, is that a good word for it? Analyzing the bytecode, yeah, so that we can then perform these checks, all right? And so to do that, what are we going to do? Let's see. I think we want to add a new file. Excuse me. And we've got program dump bytecode, program execute, and I think we want a program analyze. And we've got dump bytecode there. We're going to analyze, and now we can copy source program. Let's copy the dump to source program analyze .cpp. And now edit our include program source program analyze. And we need a test program. Let's just open test, the normal test. All right, and we'll get started here. Now, of course, starting out, we already know that it doesn't like the fact that we just copied a file and it's trying to include it twice. So we're going to have to fix that. So, oh, need to do something. One moment. I'm going to pause the recording. All right, I'm back, and sorry about that. Just had to, I could feel my throat starting to give me issues. I've had a sore throat last couple days, and so I had to get something to drink. Some, well, I guess this is peach tea flavored water now. Anyway, all right. So as I was saying, first of all, we know that we just copied a file, and let's look at that one. Oh, program analyze. And it has this thing called dump bytecode, and what we want to do is we want to instead have an analyze function that will give us some information about, yeah. So I am needing to open a window. Here we go. And in C++, we have something called pair. Yeah, that's fine. But we also, is this the site? Sure. But we also have tuple, which allows for even more. and more return types. And so what I think we want is to return a tuple of some things. And yeah, that's probably good. Now, the other thing is I'm not getting rid of all of the code yet because we're going to need it. The problem is we don't know yet what we're going to be returning. And I'm just going to say, can I do this? A tuple of void? And so we've got add bytecode. I think that this should only be an internal function. So let's so we've got a parse, a compile, and analyze the current bytecode. Sure. Void analyze. Actually, it should be a standard tuple of void. And do we need to pound include something for that? Probably. It's in the tuple library header. Okay. And since I'm here, put them in alphabetical order. Sure, why not? And let's just see if we compile as of this moment. I'm expecting there to be some resistance. Okay, tuple void program analyze const. What do you mean nothing matches it? I just created it. Oh, I didn't add const. That's why. Do that. Now it's going to have to rebuild everything because so many things rely on the definition of program. Why? Because we just rewrote it. We rewrote program. Excuse me, in the previous 2 episodes, we rewrote our makefile to get all of our stuff in there. Okay. Now, the earlier one, the the previous incarnation, what we stole from, returned a string, and for this, the dump program check, it will return a string. What we're going to do is we're going to get rid of that because yeah. Should we? Maybe verify the size of the bytecode vector so that it may be safely accessed. I'd like having that. An error. Let's just say empty result is return. Okay. Return, and then here it's going to be Can we do that? I bet so. See if that will compile. Okay, there's still other returns that it won't like, but oh, and it doesn't like the standard tuple. Can I do that? I don't think it'll let me do that. Nope. Let me do that. Why am I trying so hard? Because we're going to need to do. I'm just going to go for now because you know what? Let's go ahead and decide what we're going to need to get out of this. We're going to have a map of how do I do opcodes? Oh, just opcode to what? So I want it to be a, if I say, where are all of the jump? Or where are all of the jump T, pop, whatever. So that's an opcode, and then it should point to a vector of, would that just be size T? I think so. And this will be up positions, opcode position, or locations, places, offset. I like op offset. Normally we use that. We use a plural. And we also want to have a vector of opcode. So this is kind of like the opposite. And this is going to be called ops. And basically, no, it's not just an op. I don't just need to know that it's there. I also need to know its location. So let's a pair of opcode and size T. Yeah. So in other words, think about how when we usually dump the bytecode, what I need to know is what's the 5th bytecode? What's the 6th one? That's how we check for, oh, do I have this pattern? Yeah, I think these are the two main things that I need. And so we don't need the output. Opcode width. No, this is for the dumping. And PC is just to keep count, but that's fine. Okay, we're not doing the annotation thing right now, so whoops. There we go. We switch the opcode, and now all that we need to do is figure out what to do for each one. So we can say op offsets of opcode this bytecode PC that's going to get us a vector dot push back PC. Okay. Now, ops dot push back the pair of the opcode this bytecode PC comma something else close. Okay, and the something else is the location PC. Okay, so this is going to be that bytecode. Okay. And then this is going to be a in the order that they appear in the bytecode. Followed by the offset within the bytecode. Now, by getting there, do I need to add something is what I'm thinking. So for the opcode, if I know its offset, and if this one is the opcode I think this should not be a pair. Let's do this as a tuple of opcode size t size t. Why? Because this would be followed by their offset within the bytecode. No, that might be enough. I might only need one. What I'm thinking of, okay, so the vector value, can I say it like that? The vector itself has an index 0, 1, 2, 3. So the 0th item is an opcode. The 1 item is the next opcode. The 2 is the next. The 3 is the next. And then I should be able to say, and what is that opcode and where is its position? Okay, so that's the offset within the bytecode. This one is an opcode, and then within that, a vector of offsets. Now the question is should I go with sorry, brain stopped working because I'm thinking ahead, and I should just blurt it out. when I'm asking for where are all the jumps, do I want the ordinal? Well, I don't know if ordinal is the first, second, third opcode, or do I want offset 0, offset 3, which is the next one, offset 14, which is the next one? Which one? Maybe I want both. Maybe this one needs to be a vector of pair of size t, where a vector of position pairs with the first position being the bytecode offset and the second position being the ops offset. I think that works. So for each opcode, we're going to have a vector of pairs of words. Okay, that's fine. And then this is going to be the actual offset. Okay, I can deal with this. So up offset is sorry, brain's working. Up offsets, push back, and it's a pair. And that needs to be ops.size. Why? Because ops.size we haven't added to it yet, so the first time we come through it's going to be 0. And, well, that is correct. So offsets, up offsets is going to be the bytecode offset and then the ops offset. Sure, I can deal with that. And then ops is each bytecode and its bytecode offset. Okay. Sure. I was going to try to put a better wording there, but let's just say of the opcode. Okay. And now so dump program check, what it's going to do. Okay, first of all, we're going to return these two things. Oh boy. We're going to return a pair of, which is a tuple of 2, but oh well. Say, Corey, this is ugly. Yeah, it is. And in this case now, I might have to do that. It's a pair that has an empty map and an empty vector. Op offsets and ops. Okay. Do I need to know any of this? I do have to get bytes, and that's going to be based on size. And then, okay, but I don't need to actually compute the string. Okay, that's fine. When I go back and look at this and see how many opcodes we have and everything, I'm like, okay, I can see why we're on episode 80. All right, looks like we got enough. And now, oh yeah. 27. We need to copy that and put it there. And then standard pair of a standard map of a, what is opcode? Oh, I don't have WSL view docs HTML index. There we go. Put that back. Does opcode show up here? No, it doesn't. Oh, doesn't show up there either. Oh, I'm in the... Tang, opcode. Okay, fine. I can just put opcode. Sorry, that was a lot of work to figure that out. Huh. And this should be a pair. So that means we don't need tuples at all. Is that right? Is that what I'm reading here? Opcode was not declared in this scope. Okay, and by the way, since I'm adding this to opcode, we're adding opcode to program. Oh wait, doesn't like this. Do I not have guards in opcode? I may. So let's look at opcode. Yeah. I don't have and here I need and if. Is that how I normally do it? Yeah. All right. So it still doesn't like wrong number of template arguments. One should be 2. For which one? Is that the for pair? So I've got open, 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 close, 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 2, 3, open, open, close, close, and then that's the main one. I think that was it. Which means I need get it saved before the compile got to it. And that means I don't need tuple anymore. And this should be vector of pair, and this should be a vector of pair. Save it. Try that again. Okay, it's not liking. Opcode, vector, pair, size t, vector, pair, opcode, size t. That's what it is. Maybe. Vector. Not sure what it's not liking. Oh. Need a third one there too. Now, (108). Oh, you're right. I don't need the type. Okay, so everything's passing, and so all that we know right now is that it compiles. So little things in life that are nice. Okay. I know I'm pausing, but it's because I'm trying to figure out how to test this. Or, you know what? We can do it this way. So in test.cpp, let's find a program that is more interesting, shall we say. How about this one here? And we will say cout p1.dump bytecode. Okay, now what's dump bytecode going to do? Well, edit source program dump bytecode. We got that. It's going to print out everything, and then what we're going to do is we're going to, at the very end, auto ampersand offsets, comma, ops is equal to this analyze for Auto, and what is op offsets? It is a map of an opcode followed by I don't remember. Just look for analyze. There we go. Which, oh, followed by a vector of the two offsets. Okay. Op pairs. Nope. Op pairs in op offsets. We'll just say out plus equals opcode ooh. Oh, nope. I can do it this way. Op followed by can I do this? Can I have a double? And have this as bytecode offset opcode offset? Can I do that? Will it let me? I don't know. Bytecode offset followed by opcode offset. Followed by an inline. And we will now say out is going to be the and then for, and what is op? Op is the listing of opcodes. It's a vector. Oh no, wait, the next one. Vector of a pair of opcode and size t. Auto ampersand. The vector is going to be the opcode offset. And then what is inside it? Isn't it the opcode followed by bytecode offset? That's what I think it is. Oh, I can't use up because we would be shadowing. Besides, this was probably ops. That's all right. And opcode. Oh, let's do offset followed by opcode followed by bytecode offset. All right. So the goal is just dump it all. Now, it's probably not going to like anything I'm doing here. So 319 is the first problem. Cannot bind a non-const L value reference of type pair to an R value. Is it just because I'm trying to say the ampersand? Probably. And it's probably going to say the same thing. Maybe it just doesn't like the fact that I'm using an ampersand there. So it's not... There. See if it, if it gets through that, if it gets down to doing an error on 320, well, Oh yeah, it doesn't know what to do with all of these opcode things. That's okay. I can fix that in a little bit. So for 326, expected identifier before the closing. Oh yeah, this is the nested thing again. And now it's just not liking. Go to the first error, figure out what's going on. Funny thing is what we wrote may be working and we're spending a couple hours just trying to get it to compile. Opcode offset. What I'm going to do first is for the opcodes, I'm just going to cast this to U integer T. And then see where the errors are. Okay. Okay. I got it. Um, 322. Right here. So this is, we're going through a map, and that in turn gives us an opcode followed by a vector of these things. Yeah. That's going to be the first thing fixed. Cannot decompose on 328. That's this. Oh, yeah. Pair. What is op pair? Oh, yes. Okay, I know why. C++ vector reference. What I want is come on. I mean, the simple way is to say, is equal to 0, and there. Oh, it'd be nice if I... Is ops empty? Bytecode op. Oh, bytecode 0, which is 21. Pop. 43. Is that also a pop? Yep. And 62 is also a pop. And if this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Yeah, so this is all correct. Of course, the bottom one didn't print out anything. So we could do and now So opcode 0, opcode 1 would be at, well, whatever number 11 is. So is a peak, and it should 46 should also be a peak. It is. Okay. So that one's working. It's just why isn't the other one? Oh. That's probably why. So it's probably up higher if we scrolled. All right. 0 is opcode 9, and 1 is opcode 9. Is that right? 0 is opcode 9, 1 is opcode 9. Okay. All right, let's do one other thing. Let's get rid of the casting to a U integer. Doesn't know how to do that. We're about to fix that. To do this right, we should put it in 4. Namespace Tang, blah, blah, blah. And then the question is can we do a standard OStream ampersand operator double less than with the input being a const Tang opcode ampersand called RHS. Can we do that? Oh, yeah, of course. A standard OStream ampersand LHS. Now, if it tells us that now it can't find it, then that means, okay, it was looking for it, and we can work from there. Try that again. Of course, everything has to recompile. The only thing is that it might be the case that this has to be outside of the namespace. Undefined reference to it. Okay, it found it, but I'm really thinking it should be outside of the namespace. And we can have it as a helper to print the name of to output. of an opcode. Param LHS, the O stream, param RHS is going to be the opcode to output. And what does it return? The O stream. All right, and now we've got to make this file. The problem is it doesn't exist. So what we're going to do is we're going to copy source program dump because it already has all the names, and to be source opcode.cpp and edit our make file. And now we need opcode.o. All right, and opcode.o so we didn't have an include opcode. Oh, and I've got all these macros. Okay, so should go right here, right before the P's. Okay, so this will be opcode.o, and it is sorry, these have to be fixed. Okay, so opcode now will use opcode.cpp and dep opcode, which doesn't exist yet. And we're about to write it. Okay, so from 89 on, oops. From 89 to the end of the file, I think that's how I say that, anywhere that I see an include / opcode .hpp, it should become, well, that didn't work because I needed to escape that. There we go. It should become dep opcode. Of a user-defined command. Fine, I'll do it the hard way. There's going to be a lot of these. Okay. I may fast forward through this. We'll see. Okay. Oh, that is not right. Okay. It's just that we're missing it. Let's do some stuff. Oh, okay. So here's what we're gonna do. Just for the moment, but I'm going to do this. I'm going to say an OStream ampersand operator that takes in an OStream ampersand LHS and then a const operand ampersand RHS. We're going to go with that just for the moment. Oh, and it's not going to like any of this stuff. You know what? Okay. Fine. We're not going to need any of that. You know what? Oh, operand does not name a type. Opcode, not operand. Again, my biggest pet peeve in programming is that they don't show you the first error message unless you scroll up, sometimes a lot. And that one could have been the one that we needed, but it's impossible to know. Operand types are char and aka. Okay, so it's not finding this one in the dump bytecode. Seems like that should work. So what it's saying is that this right here, basic O stream char, so it's an O stream. And then the left, so got an O stream here. And then opcode. So is it that it needs to be in here? Let's try that. It may be. Yep, that's what it needs to be. Probably going to have to say this again so it will compile again. Okay. Now we just have to get the actual names of them. So from you know what? From 15 to 66. $15.66. I want to substitute USIN. There we go. For a single quote. All right. Now, oh wait, that's so 15. What did I say? 15 to 66. Okay. From 15 to 66, I'm going to substitute a comma for a closing, followed by a comma, followed by a new line. Well, that didn't quite work. Let's try that again. Followed by, how about an at? Why? Because I can look for an at. Just say D, N, D, N, D, N, D, N. There's probably a faster way of doing this, but I don't know what it is, and it'd probably take me longer to find it. I just know I'm going down to line 66, which means I've got about 5 lines left. All right. So I've got all of these. Now I can just remove the a triple quote. No more. Okay, I got them all. And can I say equal there we go. Else return there. That should be right. Is it because it needs to be a const? Oh, okay. Wait, isn't that what I was doing before? Int and long unsigned int. All right, now let's see if this works. Yes. Okay, and as of this moment, we can just give it a whatever, and it will print out the right name. Null string peak library. If we go up here, it's null string peak library. Now, if we edit the source and program dump, if I just want to see if this works. And that was for the pop. Do I still get a pop up here? Oh, not in this top one. I still get pops. Poke, pop, yeah. So this will work. The question is what is a fast way? Can I do this? Can I say :s, so substitute just once, this followed by that, and substitute that with opcode, this bytecode PC. How about now? Okay, close. Anything except that one or more times. There's got to be a faster way. Well, in a way there is. I could do that again. And if I make this a... Nope, I don't want to do it that way. It should only be, so from 48 down to 312. 48 to 312. Okay, so from 48 to 312, substitute that. I had to undo it. That did not do what I wanted it to do. What if I do it as A-Z? First of all, would that do it? No, it doesn't. Is that because I have to escape the quote? Nope. All right. That's not finding it there either. So, I know it's faster. Well, with the regex. Huh. Just thinking. So it's not finding that. What is Vim? How do I quit Vim? That's what. You know what? We're just going to go back. We're going to apply All right, now we get to do this is going to be a lot slower. All right, down to the math functions. And hey, if I did know Vim better, this would go a lot faster. I know it would. But you know what? I think, quite honestly, it didn't matter. It doesn't matter which IDE I'd be using. I would have to figure out a specific way of doing it. In other words, somebody's going to say, yeah, if you're just using, you know, XYZ, element of P, whichever one, you know, this would have been so much easier, so much faster. And I'd be saying, yeah, but I'd have to learn how to do it in that one as well. So it's just a lack of knowledge. What can I say? All right, so moral of the story, we've got our opcodes, we've got all of this is still correct. Now the question is would we leave this at the bottom? No, we would not. But I don't want to lose it either, especially because we're going to be coming back to it. So what I think I'm going to do is just comment it out for the moment. Look for that dump wherever it is, because it can go away. There we go. Now, a few other things just to tidy up. All of this, let's think I needed to declare those as static. Okay. That's simple enough. I know it's a very small program, but okay, so we've got program analyze and we've got the opcode. And I don't mind putting them together. It's not ideal, but I still can't believe I didn't have guards on the opcode definitions. These right here. If not define, pound define, and endif. Now I've got all of these fixed, and I'm happy with that. All right, so program analyze. Opcode printing and beginning of bytecode analysis. And yes, I should be splitting these apart, but I'm not. Now, one last thing I want to do is in the make file, we've got this macros. And I think we've got an issue of, yep, include macros. So basically from 352 52 to the end. Can I do $sign for the end? I need to substitute what? I can see include slash macros.hpp. And it was because I forgot to escape that. There we go. And replace that with dep macros. Oh, was there only one? That's fine. Not get. I'm glad get clean is not a command. Remake everything from scratch while at the same time. Make file, git commit. What is the commit message? Update. Cleaning up. reference. Okay. Now I can probably at the same time go ahead and do our make docs-pdf and let that run, because we did make some changes. So we've got stuff happening on either side. Our computer sounds like it's about to take off. All of our tests are still passing because we haven't actually changed any bytecode. We're just adding stuff. All right. And on the left-hand side, update docs for episode, I don't remember, episode 83. Episode 083, and our message is episode 083. All right, it is pushed, and where are we? 11,377, and we haven't really gotten into our optimization stuff, but we're closer than we think. So where does this put us? Right now, we have the ability to say, to analyze, meaning, maybe analyze is a bad word, but to collate. How about that? Yeah, I know. I'm just I'm kind of stopping, because I'm thinking, not out loud because I'm not saying anything, but we can say, for example, if I look at the include Tang, there we go, this one. Anytime I see a push followed by a pop, well, what are my pushes? I can say, you know what? Show me anytime I have a null value. Okay? Do I have a pop right after that? What about anytime I have an int or a float or just anything? If I have a pop immediately after, then that means I can get rid of it. So then we need to write, well, what does that mean to get rid of it? Well, I would be removing 19 and 20. Now, of course, I would have to say, make sure that 20 is not a jump target. So I would have to say, for all of the jump targets, where are you? We've got that now. We have access to that information. But if I remove 19 and 20, then I need to be able to say any jump targets that are past 19 and 20. So the next one would be at 21. You're going to decrease, right? So this jump 24, jump F pop 24 will no longer be jump F pop 24. It will be jump F pop 21. No, not 21, sorry, 19, because we'll have gotten rid of 19 and 20, and so 21 is now 19. So, oh, wait, sorry. I'm saying it wrong. 24 would be further up. So we're getting rid of 19 and 20. 21 now becomes 19, which means we lost two numbers in here, right? So 21 is becoming 19. That means 24 here should become 22. And so on and so forth. That's what I'm trying to say, at least. But, yeah. All that's to say is we're closer. We still have a few more utility functions to write, like how do I delete things out of the bytecode vector? Well, that's simple enough. You just take a few things out. How do I update everything that would be affected by that? That's the scary part. But if we can get that and we have all of our unit tests, we'll know that once we perform an optimization, once we perform a removal, that is, we can then just look for a specific optimization, and then look for another optimization, look for another optimization, keep looking until we know there are no more changes that have been made. And then if all of our tests still pass, we know that we've not changed anything, or not inadvertently changed anything. So, okay, those are our next steps. So today was to get the first one, which was just the analysis and some helpful printout help. And that is all been pushed now, and we can step back and say, yay, we got a lot of stuff done. And with that, I will say thank you again for joining me on the journey, and hope you're enjoying it. Thank you. Bye.